So the last thing we're talking about in our perception and sensation unit is depth cues. So depth perception is concerned that how we perceive the three-dimensional nature of the world. So the problem lies in the fact that the image of the world throws on our retina is two-dimensional, but we perceive the world in three dimensions. How? So we have what's called binocular cues and monocular cues. So we have two different types of binocular cues. We have retina disparity and we have convergence. So retina disparity, this takes into account the disparity. This takes account of the disparate. Why can't I read English? Images of each retina. So a depth cue resulting from slightly differing images produced by the retina of the left and the right eye. So each eye is spaced apart a few inches, allowing each eye to get a slightly different view of the world. So difference decreases with distance. So retina disparity is just saying that each of our eyes from the left and the right sees an image and it puts it together to create our whole view. So farther away, the distance or the differences will be different. So if you close one eye, look at something, and if you then open that eye and close the other eye, you'll see that the image kind of moves. Farther away objects won't move as much when you do that. Then we have convergence. So this is when two eyes are focused on a distant object. They're less stressed than from a near object. So same thing, that kind of what we do is like when we put our finger towards our nose and then we go cross-eyed, so it's harder to focus on things that are near our eyes than things that are farther away. So it puts more strain on our eyes. So retinal disparity versus convergence. We then have monocular cues. So we have interposition. So one item blocks the view of another item in the back of it. So this is the example up here. So interposition. So this circle is blocking the view of the square and the square is blocking the view of the triangle. So things, when they're overlapping, basically is what's going on here. So one item blocks the view of items in the back of it. We then have texture gradients. So this texture of surface more distant, changes in clarity, so blurring at farther distance. So looking at this picture here, objects in the background like those fields look a little bit more blurry than this nice clean clear hay bale up front. We then have what's called linear perspectives. So these produced by an apparent converging of parallel lines in a distance. So example of the train tracks, these ones up here look nice and parallel. As we go down, it kind of looks like they're converging inwards. It's not actually, it's just that's what we're perceiving as we look farther down on this linear line. The next thing is retinal size. So an image that is close creates a larger image than one that is farther away. So here's an example of retinal size. So both of these Coke bottles would be the same size. If one was placed on the desk closer to you than versus farther away, the one that's farther away looks like it's smaller, even though they are the exact same size. We then have light and shadow. So lighter objects appear closer in comparison to darker objects. So if you're looking at a picture and you see some shadows and some shading, those lighter objects may appear to be closer, and then the ones that are darker, they may seem to be farther away. Then we have the motion. So near objects are seen as moving more rapidly than far objects when the viewer's head is moving. This is like kind of like when you're in the car and you look up, things seem to be looking slowly. When you look down at the ground, it looks like we're moving really, really fast. So the position of the viewer's head, and then whether it's closer or farther away from you, how fast that seems to be moving. We then talked about some constancies. The first one we had was color constancy. So things will keep color even if lighter changes around them to make it look different. So you read through this PowerPoint, you saw a little block, and the block was the same color on top and bottom, but as soon as you put that bar on it, it looked like it changed color. So this is color constancy. So things change the same, colors that are the same will look like they're changing depending on what's around it. We then have size constancy. So size, so the same size even if it is farther away. So things that are farther away are actually the same size even though that they look the same. They look like they are different sizes. We also have shape constancy. So perceiving objects have only one size and no matter the angle. So shape constancy, so if we have a tire, if we take a tire, it's going to be round. If we then look at the side, we still know that that tire is round because a tire never changes side. It doesn't turn square. It's always going to be a round tire. We then have brightness constancy. So it is the tendency to see an object equally as bright even if the light around it changes. So this example, I believe, if you're in a room or if you're looking at a picture and everything is bright and then all of a sudden you put something in the way, looks like the things around it are darker than they actually appear to be based on what is poking up through it. This is an example of brightness constancy. So they are the same lightness, even though it looks like some parts are darker than the other. So after that PowerPoint, those two PowerPoints, you then had the depth perception worksheet to work on, and then you had an assignment to pass in. I don't know if I have a copy of it.